So what we've been studying for several years is neuroinvasive herpes viruses and how they invade the nervous system and then travel long distances along nerve fibers to establish a lifelong latent infection in your nervous system. If you've ever had a cold sore, herpes virus is in you for life. About 60 to 70% of the world population has herpes virus in their nervous system. So in collaboration with colleagues at Tufts University Medical School, Katja Heldwein, and Greg Smith at Northwestern University Feinberg School of Medicine in Chicago, we've discovered how to inhibit the viruses from moving along those nerve fibers to establish that infection. And since they don't establish an infection, but they still are viable viruses, we can use those viruses as vaccines to protect against herpes infection.
So when we were trying to investigate this virus as in its potential role as a vaccine, we tried bunches of routes of application. We tried to put it nasally and put it in the eye. We did ocular, we did subcutaneous, so it got under the skin. We tried intramuscular. And under all of those conditions, not only did it not harm the animal in any way, but it was also protective against the more toxic, more virulent virus. But because what we were looking at was the neuronal capacity, the neuroinvasive properties of it, we needed to make absolutely sure how it was going to function if it ever actually did get into the nervous system. So even though we knew it wasn't going to get in from the periphery, we had to actually conduct surgeries to get it actually into the nervous system to see how it would function once it was inside.
So currently there is no herpes vaccine available, and we think this has great potential to developing it into a human vaccine. There are herpes viruses for animals. Each species has its own virus, and so there are animal health applications for herpes vaccines. And also we can use it in oncolytic vectors for cancer treatment to prevent the vectors from entering the nervous system.
So one of the things that I think is best about the work that we've done is it's sort of like a case study for what is best about interdisciplinary work that the university really fosters and supports. So we have two groups of researchers actually who are interested in working on viruses, how they function and what their structures are. And we have our group over here that is really concentrated on neuroanatomy. And we were looking for sort of tools to find the ability to trace neuronal connections. And you get those two groups together to be looking at their particular areas of focus. And out of the marriage of those two, you get something completely new and extraordinary. You get these vaccines for a virus. And so it has immediate ramifications for health for humans, health for animals. And it's not at all what we were looking to do. Neither group was looking to do this, but with a combination, you got that result.